Hello, Lenni Lobel here with Techorama, inviting you to join me this May in Belgium for a full-day workshop, Developer Deep Dive into SQL Server. In this short video, I'll briefly describe some of the compelling features for developers that we'll be exploring in much greater depth on May 22nd at Techorama. Learn how to harness the power of windowing, which exposes a behind-the-scenes window that gives each row in the results set a scope of visibility over the entire results set, or a select partition of the results set. With this capability, you can solve many common problems for aggregations, lookups, and percentiles, easily calculate running and sliding aggregations, or look up a value in any neighboring row. You can also transpose rankings into percentiles, and then look up any value based on percentile. We'll learn about many other of the latest T-SQL functions as well, including logical, string, conversion, and date-time functions that you can use to write better T-SQL code. And we'll look at other language improvements, like throw for better error handling, server-side paging with offset and fetch next, the sequence object for sequential number generation, and metadata discovery for dynamic query situations where you don't know the schema of a result set in advance. Then we'll move on to the latest features added to the relational engine in SQL Server 2016. Learn how to use dynamic data masking to hide sensitive information, not by encrypting it, but by masking it from users that don't have the permission to see it. With row-level security, you can hide rows from different users based on custom logic that you embed in an RLS predicate function. Then you create a security policy to bind the predicate function to a table. And from that moment on, SQL Server calls your predicate function for every row in the table for every query that any user runs. In your predicate function, you can examine any values in the current row and then grant or deny access to that row depending on the user running the query. Always Encrypted is a hybrid feature that uses client-side encryption to ensure that critically sensitive data is, well, always encrypted, and that means it's never decrypted in any location other than the client. The data is encrypted in the database, but the client can still query for it, and can even query on it, all without you having to write any encryption or decryption code. Everything happens transparently through the client provider. The server provides the client with certificate path information that the client can use to encrypt the data before it ever leaves the client, so that the data is already encrypted in flight at this point. The query executes, and the encrypted results are then sent back to the client, who transparently decrypts it for the application. Stretch Database is a great way to archive old data without actually taking it offline. You can designate specific tables, or even just portions of specific tables, as eligible for stretch. And this means that SQL Server automatically moves that data to a remote database in the cloud on Azure. The archive data is read-only at this point, but is still always available to be queried at any time, and the whole process is transparent. The local SQL Server talks to Azure behind the scenes to fetch remote data when needed. And if you change your mind and you want to stop using the feature, you can reverse the migration, which pulls back all the archived data into the local database. Time travel is now possible in SQL Server thanks to the temporal data feature. Any table can become a temporal table just by adding two special period columns, which identifies the window of time that any version of a given row ever existed in. Behind the scenes, SQL Server maintains a history table to capture changes over time, but all we need to do is add for system time as of in an otherwise ordinary query. And these are called point-in-time queries, which essentially travel back in time to access the table as it appeared at a specific time in the past. So any new data added since that time won't appear in the results, and any data deleted since that time will suddenly rematerialize. And any data that's been modified since, well, that's going to appear exactly as it did at that point in time. With the newest built-in support for JavaScript object notation, you can bend and twist JSON just about any way that you need to. Store your data as relational and convert it into JSON, shaped just the way you need. Or query JSON and parse it using T-SQL and then consume it into your tables. Or store the JSON itself right inside a column, it's all up to you to decide how to best leverage the power of JSON in SQL Server. When it comes to storing and retrieving blobs, you need to think outside the box because relational databases were never designed to efficiently handle blobs. But FileStream works like magic behind the scenes and transparently leverages the back-end file system for scalable blob storage, while logically, the blob still appears as an ordinary column inside your table. File Table raises this abstraction to a new level. By utilizing the hierarchy ID data type to convey a folder structure, combined with the transparency you get for scalable blob storage with FileStream, you can expose the entire table to the outside world. The file table emulates a simple file system, such that each row in the table represents either a folder or a file. Then, users just pop open their Windows Explorer and drill down into a share that looks like a physical file system, but is, in fact, a table in your database. And just in case you weren't having enough fun yet, we'll end our day exploring geospatial. SQL Server has rich support for spatial data using two spatial models. Use the geometry data type for a flat Earth model and the geography data type for a round Earth model. Once you've got spatial data in your database, there are all sorts of ways that you can use it. Given roads and districts, find out which roads intersect which districts. Or identify the fragments of each road that run through each district. With geocoded photos in the database, which would likely be using FileStream, easily calculate the distance between any two photos. Also, calculate the area and length of different spatial types, such as polygons and line strings. And there are plenty of other spatial methods for manipulating shapes and morphing them in various ways. Hopefully, I've whet your appetite to learn more, so I hope you'll join me in Belgium this May for Techorama, and I'll have tons of demos for you on all of these awesome features for developers. I'll see you then.